But here there are 3 Cls, means they withdraws electrons and create smaller ring can show more minus a effect. Means, hello students, today we will discuss about one of the important aspect in general organic chemistry, that is nothing but inductive effect. This inductive effect is a permanent effect, means it happens in the presence of attacking reagent or in the absence of attacking reagent. So now first we should see definition of inductive effect. Just look on the board, guys. So here, polarization of sigma bond caused by an atom, polarization of sigma bond caused by an atom or group either pulling or pushing electron density through a chain of atoms. So means here it is simple. So it happened by pushing or pulling electron density through a chain of atoms. For example, if you take CH3 bond, CH2 bond, CH2 bond, CH2 bond, there group G have to take, group G. If the electronegativity of group G is more than the carbon atom, so it can attract the sigma bonded electrons towards itself. So means it pulls that electron density towards itself, guys. If the electronegativity of G atom is lesser than the carbon, then carbon can attract these sigma electrons towards itself now. So means this G group pushes electron towards the carbon atom. If it attract the shared bonded electrons, it will get partial negative charge, and that carbon loses electron density now, it will get partial positive charge. And after polarization of the sigma bond causes electron deficiency on that corresponding carbon atom. That's why it again attract bonded electrons towards itself. Then next carbon will get again partial positive charge, but this is lesser positive than corresponding carbon atom. So this effect is transmitted up to 4th carbon atom, guys. This effect is transmitted up to 4th carbon. Simply we can say inductive effect is raised due to electronegativity difference between carbon and attached group, guys. If group G electronegativity is more, so it attracts electrons and will get negative charge, then that effect is called minus I effect, means negative inductive effect. If group G has lesser electronegativity than carbon atom, so it pushes electron towards the carbon atom now, so that effect is called plus I effect, means positive inductive effect. So means inductive effect is classified into 2 categories. One is what? Negative inductive effect. Another one is positive inductive effect. Simply we can say inductive effect means polarization of sigma bond causes another adjacent sigma bond polarization. If electron withdrawing group is there, electron attracting group is there, that is nothing but minus I effect. If electron donating group is there, electron pushing group is there, electron releasing group is there, then that effect is called plus I effect. Electronegativity of X atom is larger than the carbon, that is directly proportional to minus I effect, and inversely proportional to plus I effect, guys. So that is the relation between inductive effect and electronegativity. So electronegativity is directly proportional to percentage of S character, guys. So for example, Sp has 50% S character. So Sp greater, Sp2 greater, Sp3. This is the electronegativity order for corresponding hybridization. Means more S character, more electronegativity. That means more S character, more minus I effect, guys. For example, if you take C triple bond CH, C double bond CH2, CH2 bond CH3. If you take these 3 groups, here first one is bear with a triple bond now, so it involve in Sp hybridization. Second one bear with a double bond, it involve in Sp2 hybridization. Third one is pair with single bond involving sp3 hybridization. Here there is a more s percentage, means more electronegativity. That's why this triple bonded carbon atom act as electron withdrawing group than double bonded carbon atom. That one is more than a single bonded carbon atom, guys. So this is the minus I effect order for sp, sp2 and sp3 carbon, guys. Now take another example. If you observe these two examples, here it is a double bonded carbon atom, so it involving sp2 hybridization. Here it is a triple bonded carbon atom, means it involving sp hybridization. Here it is single bonded carbon atom involving sp3 hybridization. Now here it is double bonded carbon atom, means sp2 hybridization. Now here sp hybridization carbon has more electronegativity due to presence of high s percentage. So here these group act as minus I group and this benzene act as a plus I group, because this sp carbon withdraws electrons. For example, if you see here this benzene ring carbon atom involving sp2, but attached carbon atom involving sp3 hybridization, means that benzene ring carbon act as electron withdrawing group, then that benzene ring act as a minus I group and these carbon act as a plus I group, guys. Then how to take another example. This is very important. Ring size is inversely proportional to minus I effect. Ring size is inversely proportional to minus I effect, guys. So very important point, guys. So just look here. For example, if you take a 3-member ring and how to take a 4-member ring, how to take a 5-member ring. It is a 3-member ring now. So ring size is inversely proportional to minus I effect, means smaller ring can show more minus I effect, means act as more withdrawing group, because there is a ring strain, angle strain in smaller rings. So that's why the smaller rings can show more minus I effect than a larger ring, guys. For example, this 5-member ring is attached to 3-member ring. It is attached to 3-member ring. The 3-member ring can show minus I effect. This 5-member ring can show plus I effect, guys. Minus I effect is directly proportional to positive oxidation state of an element. Minus I effect is directly proportional to positive oxidation state of element, guys. For example, X is an element with minus 3, X is with minus 2, X is with minus X without any charge, X plus 3, X plus 5, like that oxidation states are there, for example. So more positive charge is there, more minus I effect is there. So means plus 5 can show more minus I effect than plus 3, then plus neutral, minus 1, minus 2, minus 3. Like that order may happen in case of minus I effect, guys. So for example, if you take Cr plus 3 and Cr plus 5. Cr plus 5 can show more minus effect than Cr plus 3. Mn plus 2 and Mn plus 5 how to take. Then Mn plus 5 can show more minus I effect than Mn plus 2. Mn plus 5 means more electron deficient, that's why it can attract electrons towards itself. That's why it can show more minus I effect, guys. Now look on that board, guys. Plus I effect groups, these all are plus I effect groups, means they act as electron releasing groups. Downside, these all are minus I effect groups, means they act as electron withdrawing groups, guys. If you observe case 1, negative charged species has more electron density, that's why they act as electron releasing groups. Negative charge on low electronegative atom can act as more electron releasing group. So here carbon has less electronegativity than nitrogen, nitrogen has less electronegativity than oxygen. That's why that follows that order. Now if you take alkyl groups, tertiary alkyl group more electron releasing group than secondary alkyl, which is more than primary alkyl group guys. So if you compare methyl groups, so methyl means CH3 na. So if you take tritium, that act as best electron releasing group than CH3, and CD3 also deuterium. If you take deuterium here, that one act as best electron releasing group than CH3 guys. So this is important. Tertiary carbon greater, secondary carbon greater, primary. After that only we will get a methyl group guys. Now when we move that negative inductive effect groups, so if there is a positive charge, they act as electron withdrawing groups. And very important thing is, positive charge on more electronegativity atom can act as best electron withdrawing group. Here oxygen is more electronegative atom. In case of OR2 also oxygen is a more electronegative atom. But if you compare these two, here oxygen bind with highly electronegative fluorine, here it is binds with alkyl group. That's why OF2 is a better withdrawing group than OR2. Here, if you compare OR2 and NR3, oxygen has more electronegativity than nitrogen. Here both are binds with alkyl group. Here OF2 and NF3 if you compare, here both are bind with fluorine high electronegativity atoms, but here oxygen has more electronegativity than nitrogen. That's why OF2 is a better electron withdrawing group than NF3. Like that we should compare power of minus I effect groups guys. If you move to down, so NO2, CN, then aldehyde is better withdrawing group than ketone. If you look here, so here if you take aldehyde, C double bond OH, ketone, C double bond OR na. So one is C double bond OH, one is C double bond OR. C double bond O is a electron withdrawing group obviously. Here C double bond O is a electron withdrawing group obviously, because oxygen is more electronegative atom na. That's why it can create positive charge on that carbon atom. That positive carbon atom binds with electron releasing group. That's why aldehyde is a better electron withdrawing group than ketone guys. Okay, now move to halogens. Fluorine is high electronegative atom na. So that's why fluorine more minus I effect than chlorine, which is more than bromine, which is more than iodine, which is more than OR, alkoxy group, which is more than OH, then sp carbon, then only phenyl group. Phenyl group means if benzene act as a substituent, that one is called a phenyl. In the phenyl, carbon is with sp2 hybridization na. That's why pH group has less electron withdrawing tendency than a triple bond carbon atom guys. I hope you understand how they act as electron releasing groups, positive inductive effect groups, how they act as electron withdrawing groups, negative inductive effect groups guys. Now if you compare these two groups, this carbon involved in sp2 hybridization, it is a double bonded carbon atom. In phenyl ring also carbon act involved in sp2 hybridization. Now if you compare these two, here this sp2 hybridized carbon is linked with extended conjugation, extended sp2 carbon atoms na. That's why these phenyl group act as a best minus I effect group than the simple alkene group guys. If you take benzene ring, if group X present on that benzene ring, so where it attached, that position is called ipso position. So adjacent to that ipso position is called ortho position. Adjacent to the ortho is called meta position. Opposite to the ipso position is called para position. So if you take X, maybe act as plus I group, maybe act as a minus I group. For example, if you take like that, so this effect directly fall on that ipso group. So means this effect is directly fall on first ipso group guys, then ortho, then meta, then para. This is the order of effect of plus I group or minus I group on benzene ring guys. This is very important to compare acidic nature, basic nature, stability of carbocation, carboanion, like that examples guys. So you should remember ipso greater, ortho greater, meta greater, para. So this is plus I or minus I effect on benzene ring guys. Then now I want to move very important aspect, that is applications of inductive effect. The first application is stability of carbocation. If a carbon pair with positive charge, then that one is called a carbocation. Positive charge means it is an electron deficient species. If someone gives electrons, it will become stable. If someone withdraws electrons, it will become unstable. Means stability of carbocation is directly proportional to plus I effect and inversely proportional to minus I effect, guys. So directly proportional to plus I effect, because plus I effect means it electron releasing groups, minus I effect means electron withdrawing groups. If electron withdrawing group is attached to electron deficient carbon atom, that leads to highly instability. So means plus I effect is directly proportional to stability of carbocation, minus I effect is inversely proportional to stability of carbocation, guys. Now I want to move to different examples. If you take Ct3 plus, CD3 plus and CH3 plus. So tritium is a best electron pushing group than deuterium, which is best electron pushing group than hydrogen. That means Ct3 is more stable than CD3, which is more stable than CH3, guys. For example, if you take like these three compounds, I told already ring size is inversely proportional to minus I effect. If smaller ring can show more minus I effect. Minus I is also inversely proportional to stability of carbocation, guys. So more minus I is there, least stability is present. Smaller ring has more minus I effect. That's why it has least stability. So that larger ring has more stability than this one. This one has more stability than 3-member ring, guys. Now if you take these three, here it is sp3 carbon atom, here it is sp2 carbon, here it is sp carbon. Sp carbon has more S percentage, which is directly proportional to electronegativity. Electronegativity is directly proportional to negative inductive effect. Negative inductive effect is inversely proportional to stability of carbocation. That's why, so this one has least stability, because more minus I effect present on that carbon, guys. So first one is more stable than second one is more stable than third one, guys, simply. If you take this all examples, now here this is a secondary carbon because it linked with 2 carbon atoms. It is a tertiary carbon atom. This is a primary carbon atom. This is also primary, but it is a simple methyl group. I told you in plus I effect groups, tertiary alkyl group is a best plus I effect group than secondary, which is best than primary. Means tertiary can releases more electron density towards the carbocation. That's why it become more stable than secondary. Secondary become more stable than primary, which is more stable than methyl group, guys. Like that, inductive effect play very important role in case of stability of carbocation, guys. In case of stability of carbanion, just have to take that is directly proportional to minus I effect and inversely proportional to plus I effect, reverse to what we discussed. So that's it, guys. So carbanion means carbon pair with negative charge, means that carbon is with more number of electron, that carbon is with more electron density. Carbanion means carbon pair with negative charge. That means that carbon pair more electron density on it. Means if electron withdrawing group attached to that withdraws electron density from that carbon atom, then it will become stable. If electron pushing group is attached to that one, that leads to highly unstable. That means, so carbanion stability is directly proportional to minus I effect and inversely proportional to plus I effect, guys. So we can take this example exactly reverse in case of if you take negative charge on those. I hope you understand. Now move to another application, guys. Now the next application is acidic nature of organic compounds. How inductive effect play important role in acidic nature of organic compound. H plus donor is called acid. Electron pair acceptor is called acid. OH minus acceptor is also called acid. So one who donate H plus, that one is called acid. For example, MOH. If we donate H plus, that will change into MO minus after donating H plus. This is called conjugate base. This one act as acid. Acid donates H plus and become as a conjugate base. If conjugate base is more stable, that is a very good acid, guys. Acidic nature of organic compound is depend on stability of conjugate base. If it is more stable, it can ready to donate H plus and act as a better acid. If you observe here, after donation of H plus, it will get negative charge, means more electron density present on it. If electron withdrawing group is attached to that conjugate base, that withdraws electron density, then that conjugate base will become more stable. So that means acidic nature is directly proportional to minus I effect and inversely proportional to plus I effect, guys. Very, very important. Acidic nature is directly proportional to minus I effect, means it withdraws electrons from that conjugate base and that will become stable, and plus I effect is inversely proportional to acidic nature of organic compound, guys. Then acidic nature is directly proportional to Ka values and inversely proportional to pKa values and inversely proportional to Kb values and directly proportional to pKb values, guys. And more important, which is inversely proportional to basic nature, which is inversely proportional to basic nature, guys. So like that, you should remember acidic nature directly proportional to Ka, inversely proportional to pKa, inversely proportional to Kb and directly proportional to pKb and inversely proportional to basic nature, guys. Question may ask in any manner, maybe find the correct order of Ka values, or maybe find incorrect order of pKb values, or like that, any manner they may ask. That's why you should remember this. I will tell different examples. First you should understand acidic nature is directly proportional to minus I, inversely proportional to plus I. This entire thing you should remember. Now I want to move to examples, guys. So there are huge number of organic compounds. In those compounds, I filtered few compounds who behave as acids. So aromatic carboxylic acids are more acidic than aliphatic carboxylic acids, which are more acidic than phenols, which are more acidic than alcohols. So first you should remember this for comparing acidic nature of different organic compounds, guys. If you see these three examples, these three are carboxylic acids. Now take a look this compound. Their COOH, adjacent to that COOH group, CH is there, which is binds with fluorine. Here adjacent to that COOH, CH is there, which is binds with two Cl groups. Here adjacent to that COOH, CH2 is there, which is binds with CH3 group. We know that fluorine has more electronegativity, so it acts as minus I group. Here there are two chlorines. Chlorine also more electronegative than the carbon. That's why it is also act as a minus I group. Here CH3 act as a electron pushing group. That's why methyl group is a plus I effect group. I told you acidic nature is directly proportional to minus I effect. Means first two has more acidic nature than third one, guys. If you compare first two, which one has more electronegativity? We thought fluorine has more electronegativity than chlorine. That's why first one has more acidic nature than second one. But that one is wrong, because here there are two number of chlorines in case of second one. So means we should follow one important rule, that is DNP rule. DNP rule means D means distance of the group, plus I group or minus I group. Next one number. Next one is power, guys. First we should follow distance. First if you compare distance, if distance is equal, then how to go for a number. If number also equal, then how to go for a power. Means how much it can withdraw, how much it can push electron density. So that is nothing but a power. Here if you see these two examples, so fluorine at second place, chlorine is also at second place, guys, but distance is same. Now we should follow number. Here there are two chlorine atoms, but here there is only one fluorine atom. That's why 2 has more acidic nature than 1, which is more acidic than third one, guys. In case of third one, there is a plus I effect, na? That's why. Like that, we can decide acidic nature of the organic compound. I want to tell huge number of examples. Now, look at these examples, guys. Look at these examples. If you observe these examples, there COOH binds with CH3, na? This is plus I effect group. Here, COOH binds with F means these all are minus I effect groups. Now here, COOH binds with 2 fluorines. Those are also minus I effect groups. Now here, COOH is binds with, adjacent carbon of COOH is binds with 1 fluorine atom. This is also minus I effect groups. Means out of these 4, so this one is a plus I effect group, means which is inversely proportional to acidic nature. So that will get last position in acidic nature comparison. Now if you take these three, follow DNP rule. Distance, number, power. Here all are at second place, means same distance, but number is different. Here there are 3 numbers, means it gets second because it is minus I effect group. Then this will get, this one will get first position in comparison of acidic nature. This one will get second position and this one will get third position, guys. Like that we can compare. This example. Here COOH is bind with H, na. Here COOH is bind with CH3, na. Here COOH binds with ethyl group, na. So CH3 is a plus I effect group. Here CH3CH2 is also plus I effect group, but here it have no plus I effect group. Plus I effect is inversely proportional to acidic nature, means this one have no plus I effect group, means it gets first position in the acidic nature. Then methyl is less electron releasing group than ethyl, so means it is a best electron releasing group than methyl. That's why it has less acidic nature than second one. So 2, 3, like this acidic nature is there. If you see here, it is a 3-member ring with COOH, 4-member ring with COOH and a 6-member ring with COOH. Smaller ring is more minus I than larger ring. So minus I is directly proportional to acidic nature. If you compare these 3, first one has more acidic nature than second one has more acidic nature than third one, because smaller ring has more minus I effect. Minus I effect is directly proportional to acidic nature, guys. I already told you ring size is inversely proportional to minus I effect. Now have to move to another example. Now if you observe these 2 examples, here COOH adjacent carbon bind with NO2, which is a minus I effect group. COOH adjacent carbon is with fluorine, which is also minus I effect group. Then COOH adjacent carbon atom is binds with Br, which is also minus I effect group. Means more minus I is there, more acidic nature. Here all are present at second position, means distance is same. Now here only one NO2 is there, one fluorine is there, one bromine is there, na. Means number is also equal in DNP rule. Now we should follow power. NO2 has more minus I effect than fluorine, which is more electronegative than bromine, na. That's why it show more minus I effect than Br. That's why NO2 contain carboxylic acid gets first position in acidic nature, then fluorine with second position, then Br with third position, guys. Now if you compare this all, here 1, 2, 3, 4, 5, 6 are there, na. There are 6 compounds, na. So we should follow DNP rule first. Here adjacent to that COOH, it is a second place, means at second position Cl is there, 1. Next if you observe here also at second position 2 groups are there, na. If you observe here, it is third position. Third position means somewhat more distance than the second position. In the DNP rule, so lesser the distance, more minus I. So means here if you observe this, it is also second position, na. If you observe here, it is also second position, na. If you observe here, it is also second position. Now compare, if distance is same, then we should move number. Now here only 1 is there, here there are 2, here it is third position, leave that. Then here there are 1, 2, 3. Here only 1, 2. Here also 1, 2. Means here 3 number of minus I groups are there now. 3 number of minus I groups are there now. Means it will get first position. Now compare that one. It is only 1 now. Here 2. Here 2. Here also 2 now. Then we should follow power. Based on the power, NO2 has more electron withdrawing tendency than F and Cl na, means that will get second position. Here also NO2 is there, but here fluorine is there, more electron withdrawing group, but here only chlorine is there na, that's why it is second. Next NO2 will get third position. So these all are has same distance na. This one will get fourth position because least number of minus I groups na. Now if we compare third position groups like this one is the third position na. So means that will get least acidic nature, that is nothing but position number 6 guys. Like that we can compare based on distance, number and power of plus I and minus I groups guys. Sorry guys, here I missed one thing. Here second position only one chlorine atom is there na, but here there are 2 fluorine atoms, means it will get fourth position. This will get fifth position, then it will get sixth position because distance is more na. Now if you observe first one, second one, third one, here COOH containing benzene ring is binds with NO2 minus I effect group. Here also minus I, here also minus I. Means here there are 2 minus I groups, means second one has more acidic nature than the first one. If you see next one, here this one is with NO2 group, here it is with fluorine group. Both are minus I effect groups na. So NO2 has more power than F to withdraw electrons. So can show more minus I effect. Means NO2 group containing COOH is more acidic than F containing COOH. Then if you compare these two, CH3 is a electron donating group, plus I group. NO2 is a electron withdrawing group. So minus I effect is directly proportional to acidic nature. That's why NO2 containing benzene ring with COOH has a more acidic nature than this one guys. If you observe this example, it is a mixture of alcohols and carboxylic acids. Carboxylic acids are more acidic than alcohol. Earlier we discussed that. So here this COOH, 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 these 3 are carboxylic acids and these first one and last one are alcohol. Means these 2 has lesser acidic nature than these 3. Now if you compare these 3, Cl is a minus I group, CH3 is a plus I group. Now it have no minus I or plus I group. It will get second position. So it has electron pushing group. That's why it will get third position. So after completion of carboxylic acids, now we should move to alcohols. If you see here, this is bind with minus I group now. So means it has more acidic nature. That will get fourth position and last one will get fifth position guys. Like that we can arrange acidic nature. If you observe these dicarboxylic acids, there it have no any external group. Here it is attached to one methylene group. It is a plus I group. Now here there are 2 methylene groups. These 2 act as a plus I groups, means more plus I, less acidic nature. So it will get third position, it will get second position, it will get first position guys, because they contain electron releasing groups na. That's why their acidic nature is lesser. Now if you compare CH3SH and CH3OH, if you compare these two, it is thiol, it is alcohol. Thiols are more acidic than alcohols because after loss of H plus it will become S minus na. After loss of H plus it will become O minus. Negative charge on the larger atom is more stable. So more stable conjugate base means more acidic nature. That's why thiols are more acidic than alcohols guys. I hope you understand how acidic nature is influenced by inductive effect. Now I want to move another application of inductive effect. It is a basic nature of organic compounds. So basic nature is directly proportional to plus I effect, inversely proportional to minus I effect, and opposite to acidic nature of organic compound. So basic nature is directly proportional to Kb values, inversely proportional to pKb values, and inversely proportional to Ka values and directly proportional to pKa values, guys. First you should remember this one also. Amides are less basic than amines. Amides are less basic than amines, guys. Why? Amides, look here, RCONH2 is called amide, RNH2 is called amine. So there is a electron withdrawing group. Means if oxygen gets this electron, pi electron, it will get negative charge. This pair of electron and nitrogen can participate there. Then oxygen can donate pair of electron and act as base. Means in case of amide, nitrogen is not responsible for basic nature. Oxygen is the responsible for basic nature by donating a pair of electron or by accepting a H plus, guys. But in case of amines, there is a plus I effect group na, so means it is more basic than amide, guys. So amine can easily donate pair or easily can accept H plus than amide. This is also important one, you should remember. Now if you look here, a nitrogen with 3-membered ring, nitrogen with 4-membered ring, nitrogen with 5-membered ring. Smaller ring can show more minus I effect, more minus I effect is there, lesser basic nature. So larger ring has more basic nature than smaller ring, guys. Like that order we will get. Now if you see this one, this is the best example. Now here it is aromatic amine, aromatic amine, aromatic amine, but this one is aliphatic amine. Aliphatic amines are more basic than aromatic amines, guys, because in case of aromatic amine, that pair of electron can participate in resonance. That's why it cannot donate that pair very easily than aliphatic amine, guys. That's why aliphatic amines are more basic than aromatic amines. That's why that last one gets first position in basic nature. Now if we compare these three, CH3 is a plus I effect group, NO2 is a minus I effect group, and it have no any plus I or minus I. Plus I increases, basic nature increases, na, so means this will get first position, and it have no anything, that's why it will get second position. Now it has minus I effect group, na, that's why it will get third position, guys. So like that we can arrange basic nature of organic compounds. Now if we compare these three, CONH2 is called amide, here it is aromatic amine, this one is aliphatic amine. Amines are more basic than amide, na, so mean these two has more basic nature. Now aliphatic amine is more basic than aromatic amine, na, that's why this will get 1, this will get 2, this will get 3, guys. Like that we can arrange basic nature. Now another application of inductive effect is reactivity of carbonyl compounds. If you take carbonyl compound as CO, it involves in nucleophilic addition reaction, because here oxygen is more electronegative, that's why it will get partial negative charge, and carbon will get partial positive charge. Then that nucleophile can attack on that partial positive charge carbon atom. If there is a more positive charge, more attack of nucleophile is there. That means more reactivity is there. More positive charge means more reactivity. How it will get more positive charge? If it attached with minus I group that withdraws electrons, then it will get more positive charge, na? Then it will get more reactivity. For example, that means reactivity of carbonyl compounds is directly proportional to minus I and inversely proportional to plus I effect, guys. For example, if you compare aldehyde, C double bond OH, and ketone or COR, here positive charge is there, here also positive charge is there. But in case of ketone, there are alkyl groups, then those can act as electron pushing groups, electron donating groups that can increase electron density on that positive carbon atom, and that will become stable and will become less reactive. In case of aldehyde, it have no any electron pushing group. It contains only hydrogen. That means aldehyde is more reactive than ketone, because more electron deficient carbonyl carbon is present in aldehyde, guys. I hope you understand. Then move to another example. If you compare these three, 1, 2, 3, there here Cl is the electron withdrawing group. Now there is a 1 Cl, but here there are 2 Cl, but here there are 3 Cls, means they withdraws electrons and create more electron deficiency at carbonyl carbon atom that increases reactivity towards a nucleophile. Means third one is more reactive than second one, which is more reactive than first one, guys. Now if you compare these two, here chlorine is electron withdrawing group and fluorine is also electron withdrawing group, but fluorine has more electronegativity than chlorine. It withdraws more than chlorine, so means that second one has more reactivity than first one, guys. Then how to take another example. If you compare these three, here CO is attached to one CH3 group here. Here it is attached with one CH3. Here it is attached with one CH3. But this side it is attached with one hydrogen, but it is a tertiary carbon. It is a secondary carbon. Tertiary carbon act as a best electron donating group than secondary, which is best electron donating group than normal hydrogen. Means plus I effect is inversely proportional to reactivity of carbonyl compounds, because if it donates electron density towards the carbonyl carbon, that increase electron density means it cannot easily attacked by the nucleophile. That means plus I is inversely proportional to reactivity of carbonyl compound. Means one is more reactive. Then if you compare these two, tertiary is a best donating group now. Then secondary, then third one is more reactive. Then second one is more reactive, guys. Next application is reactivity of alcohols. Alcohols are nothing but ROH groups. Here alcohol reactivity is dependent on two types of cleavages. One is OH cleavage, means that is dependent on acidic nature. More acidic nature means more reactivity towards OH cleavage. Next, CO cleavage, RO cleavage, that depend on carbocation. So more stability of carbocation, more reactivity of alcohol is present in case of CO cleavage. If more acidic nature is there, more reactivity is there in case of OH cleavage. Acidic nature is directly proportional to minus I effect, and stability of carbocation is directly proportional to plus I effect, guys. For example, if you take esterification reaction, when carboxylic acids are reacts with alcohols, there OH from the carboxylic acid, H from the alcohol eliminated in the form of H2O, then we will get RCOO RNA. Means here O bond H cleavage is happen. Means reactivity of alcohol is depend on acidic nature, guys. That means if you take CH3CH2OH, CH3OH, if you take these two alcohols, CH3 is the electron donating group. CH3CH2 is also electron donating group, but CH3CH2 is a powerful plus I group than CH3OH. Plus I is inversely proportional to acidic nature now. So means CH3OH is more reactive towards esterification. For example, if you take CH2FOH is there. Now it is a minus I group now, which is more reactive than the CH3OH, guys, because minus I is directly proportional to acidic nature, guys. Like that, we can decide reactivity of alcohol in case of OH cleavage. Now, if you take that RO cleavage, means CO cleavage, so that depend on stability of carbocation. If more stable carbocation is there, more reactivity is there. So that carbocation stability is depend on plus I group, guys. For example, if you take Lucas test, alcohols reacts with zinc chloride and HCl and change into alkyl halides. Here entire OH group is replaced with Cl. So means RO cleavage is happen. So means it depend on stability of carbocation. If you take tertiary carbon, secondary carbon, primary carbon, mean tertiary alcohol, if you take tertiary alcohol. Now we have to take secondary alcohol, now have to take primary alcohol. Tertiary alkyl group is a better electron releasing group, better plus I effect group than secondary. Which is best electron releasing group than primary So plus I effect increases, stability of carbocation is also increases. Means tertiary alcohol is more reactive than secondary. Secondary is more reactive than primary. In case of Lucas test, here CO cleavage is happen That's why it depend on stability of carbocation. So if OH cleavage is happen, those type of reactions depend on acidic nature of alcohols. If CO cleavage is happen, those reactions are depend on stability of carbocation. Like that, plus I effect or minus I effect influence on reactivity of alcohols, guys. I hope you understand about inductive effect and applications of inductive effect in general organic chemistry. Inductive effect is one of the electron displacement effect, guys. I hope you understand plus I effect and minus I effect and how it affects on acidic nature of organic compounds, basic nature of organic compounds, reactivity of carbonyl compounds, reactivity of alcohols, and stability of carbocation and stability of carbanion. If you understand, if you learn something from my video, just like this video for more organic chemistry videos or for more chemistry related videos for getting good percentile in JEE main and for getting good marks in NEET examination, guys. So just like this video, if you are new to this channel, just subscribe this channel for more videos, guys. See you in next class.